Welcome to Aion's Information Center. We are going to provide information about cathodic protection and techniques used.
When it comes to infrastructure, mild steel is the primary choice for many applications. However, its exposure to moisture in various settings like bridges, offshore structures, storage tanks, and underground pipelines increases the risk of rust and subsequent deterioration. To combat this, protecting steel against corrosion is crucial and offers several effective methods. While paint and other coatings acts as a reliable barrier to shield metal from moisture, it does have limitations such as susceptibility to damage and impracticality for certain scenarios like protecting rebar within concrete. This is where cathodic protection proves invaluable. Corrosion is an electrochemical process, essentially a chemical reaction that functions akin to an electrical circuit. It involves two distinct steps: reduction and oxidation, occurring at separate locations. The conductive metal allows for the flow of electrons from areas of low electric potential, known as anodes, to areas of high potential, known as cathodes. As electrons move, the anodes lose electrons and undergo corrosion. Interestingly, even within the same piece of metal, different sections may possess slightly different charges, fueling the corrosion cell. Given the prevalence of steel in infrastructure and its vulnerability to corrosion, protecting it becomes a cost-effective approach. While paint serves as an effective barrier, cathodic protection offers additional advantages, especially in situations where paint falls short. By disrupting the electrochemical circuit of corrosion, cathodic protection can safeguard metal structures, extending their lifespan and minimizing maintenance expenses. There are two main types of cathodic protection. In the case of galvanic or sacrificial anode, cathodic protection uses a more easily corroded metal, such as zinc, aluminum, or magnesium, called a sacrificial anode, to provide the external source of electrons. This sacrificial anode corrodes instead of the protected structure, sacrificing itself to protect it. Impressed current cathodic protection is a method used to prevent corrosion of metal structures by applying an external electric current. It is typically employed in situations where sacrificial anode cathodic protection is not sufficient or feasible. In impressed current method, a direct electrical current is generated by an external power source with a rectifier. This current is then conducted to the metal structure that requires protection. The current is intentionally applied to the structure in a way that opposes the natural corrosion process, thereby protecting it from deterioration. It is commonly used in larger and more complex structures, such as pipelines, storage tanks, and offshore installations. It offers greater flexibility and control compared to sacrificial galvanic anode method, as the current can be adjusted to serve specific requirements. By providing a continuous and controlled flow of current, this method effectively mitigates the corrosion process, extending the service life of metal structures and reducing the need for maintenance and repairs.
We are specialists of cathodic protection and corrosion mitigating systems. For more information about corrosion mitigation services and systems, please contact us. We have a team of experts ready to answer your questions and help you get what you need. Aion. Orchestrating precision, securing your future, today.